R2 is with Brilliant Materials. I think Thomas already mentioned them. And they work on organic materials for OPVs. Very, very good materials, excellent company. And he'll be telling us about the scale up of active layer materials for OPVs, organic photovoltaics.
Yep, that works for me. So I'll just say next slide, I guess, when I'm good to go.
Okay.
Yeah, so thanks for having me. Sorry for the technical hiccup. Thanks as well to Thomas for the lead in. Appreciate it. So I am from Brilliant Matters. We are a company in Quebec City, Canada. We've been operating since 2016, and we're specialists in organic and polymer semiconductors, which are a relatively new class of material that can be used in printed electronics. So new types of electronics require new types of materials. We do scale up of these materials, fundamental research, quality control, and we do some prototyping. We have a staff of about 20 people right now. And a couple of years ago, we moved into a new facility just south of Quebec, just southwest of Quebec City, Canada, where we have fully equipped fine chemistry labs for the synthesis of organic materials. Sorry, Kasia, next slide. Yeah, so we have fully equipped chemistry labs for like R&D on small scale to make new materials, study their properties. But also once we find a promising material, we have the facilities, the equipment, and the expertise to scale them up to the kilogram scale and beyond. We also do quite a lot of chemical analysis and method development because these are semiconductor materials. They're very sensitive to different properties or impurities. And we do some printed electronics prototyping. So, we're not at the level of a lot of people here who are making printed electronics devices, but we can test them sort of in basic devices to make sure they're doing what we want them to do. Next slide, please. So we make these materials called organic semiconductors, which are hydrocarbon-based materials. They basically have an alternating double single bond structure, which gives them semiconducting or conducting properties. And by using organic chemistry, we can change all sorts of things about them. So if you're making a solar cell, you might want to absorb a specific color of light and let other colors through. And that's possible with these types of materials. So Brilliant Matters makes these organic semiconductors in the form of highly pure powders. And these go out to our customers and partners at research institutions, universities, and printed electronics companies. They can be formulated into inks because they can be made soluble, and then they can be printed using methods like roll-to-roll printing, inkjet printing, or various types of printing, depending on the type of device you're looking to make to produce organic electronic components. So shown here is an organic solar cell, which is a field we've been very, very interested in since we started the company. And it's what I'll be focusing the rest of my talk on today. Next slide, please. So organic solar cells, we believe that this is a revolutionary power source and an energy source for the future. Some of the advantages Thomas already covered in his previous talk, but they can be made at low cost and with a really low energy footprint, basically through roll-to-roll manufacturing. They have a very high power to rate ratio. They're essentially a lightweight plastic that can generate power, and they're made from truly non-toxic and earth-abundant feedstock. It's quite similar to the organic dyes you'd find in your jeans and a piece of plastic. As was mentioned in the previous talk, they work really well under various light intensities. So not only can they work outside under the sunshine, but they're powerful enough to harvest the light from inside my office here, where we have about 200, 300 lux of light intensity. So in the IoT market, they're gaining attractiveness as sort of a battery replacement with the potential to keep a lot of batteries out of landfill and contribute to a greener IoT industry. We also see some early interest from applications where typical solar cells may not fit. So in building integrated and building applied photovoltaics or agrivoltaic, maybe where the semi-transparency and lightweight are really must-haves and not nice-to-haves. Long-term, as the technology goes up, we think it'll be part of the next energy revolution. Kasia's one slide ahead of me there, but that's okay. Can you go back, Kasia?
Sorry about that. So is it
It's okay. It's like automatically changing, I guess.
Yeah, this is. I think I'm going forward, right? No, which one is it? Okay.
Back like 2 more slides. There we go. Okay, let's start here.